Welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences, ITB. So we're still going to talk about limits, continuity, and derivative. For the special subtopic, we will discuss about limits at infinity. Okay, so we are going to talk about limits at infinity. Infinity is not number, it's just symbol for something that is bigger and bigger. How big? 1,000, 1 million, 1 billion, 1 trillion, and so on. Okay. If we say x goes to infinity, it means the number is getting larger and larger. What about when x goes to minus infinity? It's getting smaller and smaller. Okay. So if I have limit x squared when x goes to infinity, I can imagine this 10 10 squared is uh, 100. When x goes to 100 squared, that is 10,000. And if I can substitute this, it's getting bigger and bigger. So it will be infinity. Okay. What about when limit of minus x cubed, x goes to minus infinity? So I imagine this minus 10 cube is 1,000 minus 1,000 times minus, so you have 1,000. Okay, if you have a hundred minus 100 minus 100 minus 100 cube, it will give you minus 1 million times times minus, so it should be 1 million. So if you get x getting smaller and smaller, it will be getting bigger and bigger, so it will give you infinity. What about limit x goes to minus infinity when 1 divided by x? So I can imagine this at 1 divided by minus 10. This is minus 0, 1. What about 1 divided by minus 1,000? It will give you minus 0,001. What about when x is 1 million? Minus 1 million. So this division give you minus 0,0000001. So when it goes to minus infinity, it will goes to 0. Okay, let's look at this limit. Okay, this is obvious. This is obvious. We can just plug in. But what about this one? What about this one? But what about this one? Let's look at this. So for this kind of problem, we have to divide all the denominator and the denominator and the numerator with the highest degree of the polynomial. So x minus 3 is polynomial of degree 1. 5 minus 2x squared is a polynomial of degree 2. So I have to divide this by the highest degree of polynomial, that is x squared. X divided x squared divided by x squared. The denominator also divided by x squared divided by x squared. Don't forget, this is just the same. Why? Because we are dividing the numerator and the denominator with the same value, that is x squared. So this is allowed. This is the same as this limit. This limit is the same as this limit. Okay, because you just divide the numerator and the denominator with the same value, that is x squared. So this is allowed. But what about this one? This is, I can simplify this. This is x divided by x squared is 1 over x. This is 3 over x squared. 5 over x squared minus 2x squared divided by x squared. X squared divided by x squared is 1. Remember, x goes to infinity, yeah? Okay, 1 over x, the same. It will give you 0. And what about this one? The same. Something divided by something that goes to infinity or minus infinity, it will give you 0. So I have 0 minus 0 divided by, this is divided by x squared, 0 minus 2. So you have 0 divided by minus 2, so you have 0. Okay, what about this one? Let's look. We can divide this by the highest degree of polynomial, that is x squared. You can divide it by this x squared. Don't forget, that this form is the same as this form. Okay, so this is equal. 5 divided by x squared, when x goes to infinity, it will give you 0. What about this? It will give you minus 1. This will give you 0. This will give you 0. So I have minus 1 divided by 0. Don't forget, minus 1 divided by something that goes to 0. Minus 1 divided by something that goes to 0. Okay, yeah? So you have minus infinity, but we don't write this, okay? We don't write this because minus 1 divided by 0 is not divine. Minus 1 divided. So we just look at, we just imagine this as minus 1 divided by 0. Don't forget, it goes to minus 1 divided by 0. It will give you minus infinity, yeah? Minus infinity. Okay. Try to find this limit. Okay, yeah? This is okay. You look at this. The dominating term is this one. So it will follow the dominating term, that is minus infinity. Okay. What about this one? The dominating factor is this x cubed, x to the 4. So this will dominate. So to find this limit, I just substitute this into this term only. Okay, when this goes to minus infinity, minus 10, minus 100, minus 1,000, minus 1 million, and you will get this plus infinity. So because it will go bigger and bigger, yeah, because it is to the 4. What about this one? You have to divide by the highest degree of the polynomial, that is x cubed here. So x cubed divided by x cubed minus 3x divided by x cubed divided by 5 divided by x cubed minus x cubed divided by x cubed. Okay, and you can find the limit there. The same goes here. Try to find this limit, okay, as your exercise. Okay, if the limit at infinity is always the same as the limit at minus infinity, generally not the same, but look at this. At when x goes to infinity, it will goes to this height, this value. It will goes to this value. Okay, this height. So if I have this one, it will goes to minus infinity. It means that it will go, when x goes to infinity, it will go to minus infinity. Okay, it will go downward. Okay, what about this one? When x goes to infinity, it goes to some height of the value. So the limit of this function at x goes to infinity is some value. But when x goes to infinity, it has another value. Okay, and this height is not the same, yeah? Plus, minus. So in general, the limit at x goes to infinity and x goes to minus infinity is not the same. We can look at this graph, okay, yeah? But the exercise given to you is always the same one, okay, yeah? Okay. Next, we will look at the infinite limits. Previously, we look at the limit at infinity, but now infinite limit. It means that when x goes to 0, this goes to infinity or minus infinity, yeah? So like here, the left hand and right hand side of limit is different. Give it a try by substituting x that near to 0 from the left. Left of 0 is minus 0, 1. Minus 0, 1. 1 divided by minus 0, 1 is minus 10. I can go closer. Minus 0, 0.01, it will give you minus 100. Minus 0.001, more closer to 0 from the left, it will give you minus 1,000. So from the left hand side, x goes to 0 minus of 1 over x, it will goes to minus infinity. What about when x goes to 0 from the right hand side? 0, 1, 0.1, 1 divided by 0.1 is 10. More closer, 1 divided by 0,01 is 100. More closer, 1 divided by 0,001, it will be 1000. So when x goes to 0 from the right hand of 0, this function will give you the height that is getting bigger and bigger. From the left hand side, getting smaller and smaller. Okay, so limit 1 over x when x goes to infinity. 0 is infinity. When x goes to 0 minus, it will go to minus infinity. Okay, this is example. Try to do this on your own. Just consider this, yeah. Okay, just consider this. When x goes to 2, when x goes to 2, let's try this. Okay, number 2. When x goes to 2 from the left hand, I mean 2,1, 2,001, 2,0001, it will give you this positive number. What about this? 5 minus 2 squared, 5 minus 2,01, 5 minus 2,001 squared, it will give you positive also. But this is positive divided by something that goes to 0. Why? Because 2 minus 2, this is goes to 0. So it will give you something, some value divided by 0 but positive. So it will give you plus infinity. What about x2 minus? I can substitute 1,9. 1,9. It will give you divided by 0,1, it will give you 10 times this. What about 1,99? So you have this become minus 0,01. So you have minus 100 times this. This is positive. This is always positive at x near 2, yeah? So positive times 100 times 1,000 times a million. So it will give you minus infinity when x goes to 2 minus, and when x goes to 2 plus, it will give you plus infinity. Okay, yeah. Okay, next we will talk about derivative, but at this occasion we have discussed about limits at infinity and about infinite limits. Thank you.